Good. So thank you, Linda. And so we're back live. We've got three of us here. The other two are still on breaks. But anyways, we'll get started, Heather, so we don't have to cut you short of time because we do have a noon cutoff because of meetings that we have scheduled. So
Yep, no problem.
welcome and thank you for being with us.
Yeah, thank you. Thanks for having me. Linda, can I share my screen? I did.
Sure, let me just make you a co-host, and then you can.
Yeah, I prepared some slides so we could just talk about some things, or if you just have questions, that's fine too. I mean, either way.
Did you testify in the House?
I did. Yep.
Yeah. Good.
Yep. Okay, so let me see here. Okay. All right. Yeah, so I was going to talk about, whoop, that's the end of my talk. We don't want to do that. Maybe we do. Yeah. Yeah, so I was just gonna go through the pests again, kind of what's happening in row crops. I caught the tail end of the last gentleman that was talking about apples, I think, and other tree fruits. So this, my work is really focused on, row crops, but I also own and operate a vegetable farm, and so I mean, these are pests we deal with quite a lot there. And I'm also a beekeeper. I don't know if people know that as well. I don't have a ton of hives, but I have 12 to 15 every year around my farm. And so I sort of value all of the aspects of what we're dealing with here and really see all sides of it. So let's see here. I'm Heather Darby. I think most people know that. I'm with the University of Vermont Extension, and I'm an agronomist and soil scientist. And I've just celebrated my 21st year here. So, I've seen a few things now over the years, and, definitely I've seen issues with the pests that we're applying seed treatments to control. The primary pest is seed corn maggot, which is getting close. Really, the first generation that will probably come out here in the next couple of weeks. So it has multiple generations a year. It's a fly, and so they have a short lifespan, but they have several, like I said, generations every year, 3 to 5, and they'll start to hatch from these pupa over here pretty soon. So you can see, after 270 growing degree days, that's when they'll hatch. And it's been a warm winter. And, now spring really hasn't been too warm, but it's warmer. So we're over 200 GDDs right now. Last year, we didn't hit that until the first full week of May. So we're that much ahead of schedule right now for growing degree days. And growing degree days, for those that aren't familiar, it's kind of a way that we measure warm temperatures in agriculture. So we use kind of this base growing and maximum growing temperatures and calculate growing degree days. So, at 270, the egg or the flies will hatch out of these little pupa. The pupa are in the soil, or on the, sort of the edge of the fields, or in the fields themselves. So wherever, the maggots, or the flies laid their eggs and the maggots hatched, and then the maggots pupate. So once the flies emerge, they start laying eggs. They are really attracted to, they're flies, they're maggots. Like they're attracted to rotting material. We've all seen maggots before, and you know where you've seen them. So, that's what they're attracted to. This particular seed corn maggot, it has a name, seed corn maggot, but it actually, doesn't just lay eggs next to corn, right? It's a pest of a lot of crops, and it's just kind of by, in some ways, accident. They're attracted to lay their eggs where there's a lot of decaying organic matter. And so we do see, a lot of seed corn maggot damage in those areas. And where I see it on my own farm is when I plant like early crops like radish, as an example. And many of you may have seen this in your own garden. And you pull those radishes out of the ground. They're the first thing, right, that you get to eat out of your garden. And there's like a little wormy maggot in it. And that's seed corn maggot, basically. So, they're not after the corn or the soybean or the radish seed. They're really just opportunist. And if there's seed laying in the ground that's really yummy and a lot of food for a maggot to eat, they're going to attack it, essentially. So again, they're really attracted to these decaying organic matter. Once the eggs hatch and the larvae are in the soil, they go after other organic matter to basically feed on and decompose. That's what they do, and then they'll pupate again, and the whole cycle starts over. We found last year the cycle seems to be about every 30 to 40 days, but again, it really depends on growing degree days. So, all right, so it's a bit unpredictable how much damage it'll cause. I mean, they're always there. They're always in the, in our environment. But really, as far as crop damage goes, they seem to cause the most damage when you plant a crop early, the soil's cold, it's in a high residue, high sort of decaying organic matter area, and it takes the seed a little bit of time to start growing. So the longer that seed sits in the ground, the more kind of predisposed it is to anything, right? To this maggot, to fungi, to diseases. So, as we plant during cool weather and wet weather, again, in these like high residue soils, the risk goes way up. And if planting and that period of time occurs when these seed corn maggots are flying and laying their eggs, then we have some trouble. So these kind of things need to line up to have a real significant outbreak of the pest. The issue is that it's really unpredictable, right? We just don't know. We just don't know if and when it's going to happen. So they are emerging based on growing degree days, but farmers are planting when the time is right for them. And that is all over the board these days, right? If that ground dries out enough, people are out planting much earlier actually than we used to. And a lot of that has to do with climate change. So, we've also had really early springs where it's been very warm, and this probably wouldn't be an issue, but it's just really unpredictable. Okay. I already said all this. So what controls are available besides pesticides? And, there are cultural controls. So, cultural controls are waiting for the soil to be warm so that you get rapid germination and really quick seedling growth. But that isn't realistic for the majority of individuals, because it could be warm, but we could be getting a month worth of rain. So again, farmers plant when the conditions are good enough to get the crop in the ground. You know, it's funny, my husband is from Iowa and now he farms here, and it's just, he said, I'm never going to wait again. You know, you just can't wait around here. This may be your only chance before you start getting this like long period of rain or even cold weather. So, you know, sort of delaying your planting doesn't generally work for most of the farms. Now, people will say, what about organic farmers? Well, organic farmers who are planting corn or row crops, especially, you know, on dairy farms or crop farmers, they usually do wait a bit longer to plant. And a lot of that has to do with the fact that they also don't have any other seed treatment for fungus or water molds as well. And usually the number of acres that they have is also a lot less. And so waiting to start planting corn when everybody else is kind of in the thick of it, you know, is feasible, I think, for people that don't have that many acres to plant. So that is a practice that people can use. And it doesn't always work either, but, you know, it sort of reduces your risk. So maggots are attracted to decaying vegetation. So this is one of the reasons that our farming system in Vermont has been very conducive to this pest, because we have a lot of sod or hay fields. We have fields of sod in rotation that get plowed under. We have a lot of green manure going down on the ground, you know, in cover crops. And we also have a lot of animal manure. So when we're applying all of that to a field, especially in the spring, and mixing it into the soil, that is just very, very attractive to the flies to lay eggs. So again, they're not after the corn. They're after this kind of cues of rotting vegetation. So, you know, that again is just one of the reasons why we do see these problems in Vermont and other places, you know, big row crop areas that are, you know, sort of conventional row crop with no manure, no cover crops, no sod. Yeah, those systems are way less conducive. So, you know, it is different here. We also have cooler, wetter soils. We've made a lot of headway on no-till, but we still have the majority of our farms that are tilling. So we do have a pretty conducive system for this pest.
Heather, does
Yeah.
that have anything to do with why our farmers are using neonics to?
Yes. Yeah, absolutely.
Yeah, we'll
Yep.
get that, I'm
Yeah.
sure.
Yep. The maggot populations are much, much higher following a legume plow down. So like if somebody has plowed down a field of alfalfa or clover, that is, for whatever reason, really, really attractive to seed corn maggot. So we do know that conservation tillage can result in lower seed corn maggot populations, but I will say there's been no research, and actually only one or two papers that I could find in the literature, you know, since 1992. So there's really no current research on how today's production system here in Vermont and other places too, but in our case, right here in Vermont, how does our current management impact our risk, you know, to seed corn maggot? So we need more information. So again, you know, there's been a little bit of work, and this is it. These are the papers. They're all by the same person. And they were over 20, 30 years ago. So, and these are in Ohio, I think. I can't remember where they were doing this work, where they were looking at cover crop residues and no tillage, you know, and they found when cover crop residues were worked into the soil, they were very conducive to seed corn maggot. When there was no tillage, the populations of maggots weren't as bad. So again, we don't have any current information. And, on this pest, with the practices we use today, which are cover crops, reduced tillage, we still have a lot of manure going on the ground. The climate has changed. All of these things, we just don't have a good understanding of how these pests are going to impact today's production system. We have no understanding, because we've been using neonic treated seed since before we've been doing those things.
So it pays to do no-till then. If you want to get going early, use no-till, but seems like Richard Nelson was saying yesterday, if we have a cold spring, seems like he needed to till his land to get
Yep.
it whopped up so it would heat up better so he could get the corn in the ground.
Yeah.
Yeah. And I think, no-till, it's not going to be a practice for everybody. There's great reasons to do it. And a lot of people are now, but it doesn't always work, so, I think, those situations are probably less conducive to seed corn maggot in most years, but not everybody's going to be able to do it. So,
Yeah.
yep.
Dr. Darby, could you just remind, so the no-till, how does that help prevent or keep some of the maggots away?
Yeah.
Can you just tell me how it works?
Yeah. So the maggots are really attracted to, and these are the flies, right? Are attracted, they think, to these like sensory cues of decaying organic matter.
So when it's sort of rotting on the top.
Yeah.
So rotting and also, probably the smell of the soil, right? So that means it has to be tilled, and the rotting matter that's tilled into the ground. So it's really like a combination of both the sort of sensory cues, from probably the smell of soil, the active decomposition of organic matter when you till it into the ground. All of that seems to be very conducive to the maggots or the flies laying their eggs. Now, again, you could have that situation, but you could be planting during a non-flight time, right? Because they're only really flying on a cycle. So if you have that situation and you're in peak flight of this pest, you're going to have some problems, likely, right? And so all these things kind of line up, and that's when you have real issues.
So I'm showing my ignorance, but I didn't know that all of these things had a sense of smell.
Yes. Yep. There are different cues, that would attract.
Different.
Yep.
Mosquitoes.
Yeah, all different cues, right? So if you leave your garbage out, all of a sudden you're like, oh, or roadkill, whatever, that just the flies are attracted to the smell of a dead, decomposing something.
The flies usually get there before you do.
Yeah, exactly. Yep.
Yeah.
So
No.
These maggots are all laid by flies.
And this, again, it's an ignorance question, but flies also, they're a pollinator, right? Or no? Or some things that I don't always think of as pollinators.
Yeah, some flies are pollinators, different, there's all kinds of flies. So, these are different than other flies that may actually act as pollinators.
Yeah, okay, thank you.
So the other pest farmers are trying to control with these seed treatments include wireworms. And you probably best know a wire, well, I'm sure you've seen them, but if you know what a click beetle is, a click beetle is an adult wireworm, basically. So, they're soil dwelling organisms. They're, the click beetles themselves are really valuable. The wireworms, though, can cause a lot of damage, especially in like potato production, which is why a lot of potato growers might coat their seed potatoes with neonicotinoids. But wireworms, they build up in sod. So, we have a lot of sod. And, with big, massive root systems of grass ground, it doesn't really bother the grass. But when that grass gets turned over and something else is planted, it can cause a huge amount of issues to that subsequent crop. So here's a wireworm. I'm sure many of you have seen those. But, again, for us in Vermont, when people are rotating from sod into corn or soybeans or potatoes, wireworms can be a significant issue. And again, they're attracted to, decaying material that they're going to break down. But they build up significantly in the sod years of a rotation, in Vermont.
Do they make it through the winter in the ground or?
Yeah. Yep. Yeah, they can cause a lot of damage, in a cornfield. They can, for a few years actually after sod, they can be quite a problem if you have high levels. So
What other product could you use to protect the plant from these wireworms?
at this point, there are other things available, but a lot of farmers aren't set up to use them like they used to be. I'm sure you've heard this. Farmers, like old corn planters, used to be sold with an insecticide box. And so farmers would put the insecticide in these boxes and it would get applied at the time of planting. And then, these seed treatments came on the seed where that insecticide was already on the seed. So they didn't have to use those boxes anymore. And now I don't know if you can buy a planter with insecticide boxes, So, that would be the other option at this point.
Dr. Darby, can I just ask quickly, are the wireworms, are they an invasive or have they been around? Are they native to this area?
I would think they're probably native, but
Okay.
I don't know 100%. Yeah.
Okay.
But they're not invasive that I know of. So this is a pest that you can actually scout for, if you're going in, you're rotating. You can actually go out and scout for wireworms pretty easy and know if you're going to have a problem. So you could do some scouting here, where the seed corn maggots are a little bit harder because, their flights and timing and the damage is a little bit less predictable. But with wireworms, you can go out the fall before, the spring before, and you can, put out traps and you can figure out if you're going to have an issue or not. So that, we can do things there. There's different ways to scout for them, The other pest is grubs, white grubs. This is a big problem as well in sod fields. So this was in the spring of 2023 here in Vermont. You can see this field is completely wiped out, and that's all from grubs. And you can see, that's disgusting. Oh gosh, it was so gross. All you had to do is stick a shovel in the ground. You can see the pile of them there.
Wow.
So they had built up, they take a while to build up, but they build up in sod. When the conditions are right, the populations can be really high, as you can see here. This particular farm, they did grow corn. And so really the recommendation here was to, till up the soil, expose the grubs, to the seagulls, basically, to get the birds to come in, and then, plant to corn that was treated at a high rate of neonicotinoids. Otherwise, I'm not really sure. This field would have had to been fallow for a little while. So, so these problems exist here. They're not made up. They're still a problem. And again, we have a conducive system here. The crops we grow, the type of management we use, the amount of organic matter we have, they can, all create issues, pest issues.
Heather, how old is that cornfield? Is it like 2 years? Did they miss a year of planting or?
They did not. It was late actually, once they realized what was going on here. You can see the apple trees were blooming. And so they did end up getting the corn in the ground, but it was a little late by the time they figured out really what to do.
So Heather, this is kind of off the topic, and I know I don't want you to have to compress anything, but my lawn at home.
Yeah, same thing.
No. At times, I would see crows out there.
Yeah. Yep.
And they're after grubs. So then
Yep.
I hired this company to come in and do something to the lawn. I don't know exactly what, they're pellets or something. So am I gonna wind up killing bees because these people came in and it works, by the way, okay? After a year or two, I got my lawn back. It looks great. The crows don't come anymore because there's no grubs apparently to eat. So
Yeah.
just wondering.
Yeah, I don't know what.
Can you visit Rutland County at some point and stop by Senator Collmore's house?
Yeah, I know.
Just don't forget to invoice him.
I get a lot of calls on people's lawns and grubs. It is a real problem for people. There are, some biologicals that you can apply, and they take a while to sort of get established and going. But over time, they can control grubs. But these grubs have quite a long life cycle. So these will eventually be like maybe Japanese beetles, maybe, so they do take time to sort of build up populations. It can cause problems in people's lawns. I don't know what they treated with, if it was a chemical or a biological, but yeah.
Sorry.
In this case, by the time you realize something's happening out there, it's too late for this field. You're not going to go out. You got to reseed it, anyway. And their life cycle is over by this point, right? They're going to pupate and become a beetle. So they've reached max population, but they're going to be there long enough that you can't grow a crop unless they're treated. So in agriculture, you're kind of dealing with that piece.
Short growth stuff.
Yeah. So I wanted to take a little time to talk about the research that we've been doing with support from the Ag Innovation Board and also from the EPA to look at neonicotinoid movement in surface and subsurface water. So basically runoff and what is coming out of tile. And then to start looking at neonicotinoid persistence in soil and movement. And some of this work we've been doing down in St. Albans Bay at a research site that I have down there on a commercial farm along the Jewett Brook. So it's just a picture of it. So it's in St. Albans, down in St. Albans Bay, again on a commercial farm. It's heavy clay soils. And, you know, the Jewett Brook's a heavily impaired watershed, which is why we're working down there. The goal of the project is to look at different best management strategies. So cover crops, no-till, tile, you know, manure injection, and look at water quality improvements over time. So that's the goal of the project, but we're also using this site as an opportunity, since we're collecting water all the time, to look at neonicotinoids in the water and in the soil. So this is just the site, and these are the different like sub or micro watersheds within the site. So we have North Surface, it's called. And so this little purple box here or circle is where we collect the runoff, surface runoff that comes off of that watershed. Then we have a tiled watershed, and we collect surface and runoff coming out of or water coming out of tiles. We have another tiled section and then another surface section. So basically looking at
How big are those sections, Heather?
they're quite large. They're about 3 to 4 acres.
Oh, good size.
Yeah, they're good size. Yep. And again, this is in corn now. It wasn't a alfalfa, and when we started the trial, we turned it into corn. I don't need to give you all the details, but so last year we started collecting neonicotinoids. We had a ton of rain, as everybody remembers. So this is just the amount of rain events we had, a lot. You know, it wasn't as bad as some places in Vermont, but you can see it rained pretty much all the time, even if it was a little bit. So just to put that into context, these were all the sample events and where we sampled from. So quite a few sample events because it was raining all the time. And we were collecting water out of the tile and off, you know, from surface runoff. All right. Again, just showing our, when we were doing things out in the field, you know, when we were cover crop or when we were terminating cover crops, planting corn, etc. It's a commercial site. And then the little red stars on the bottom are when we were, when we would get enough runoff or water coming out of the tiles to sample. Okay, so we didn't sample after every rain event because not every rain event causes runoff, thank goodness, or causes, you know, water to drain out of tiles. But you can see we had quite a few collection points. Okay, so we also collected soil to look at neonicotinoids in the soil at the beginning of the season, in the middle of the season, at the end of the season. So this was in its 3rd year of corn silage, and it has had historic use of neonicotinoid treated seed, and this is a heavy clay soil. So over here, before planting, pre-plant, we collected soil from, you know, the surface to 2.5 inches. And then we also took a soil sample from 2.5 inches to 6 inches. And we took a number of samples. So 87% of the time, nearly 88% of the time, we could detect neonics in the soil samples in the top 2.5 inches. And so the detectable level for the ag lab is 2 parts per billion. And we were detecting, you know, almost 4. As we got deeper into the soil profile, we picked up neonics less. So we only had detectable levels, you know, 43% of the time. So not all the samples would have neonics in them that we took, but 43% of the samples did. And the levels were a bit higher as we went deeper into the soil profile. Okay, so that was before we planted. 187 days after we planted, so on November 3rd, we planted on the 15th of May, you can see that, again, most of the samples in the top of the soil had detectable levels of neonics, and the levels went up a bit. And deeper in the soil profile, the amount of neonics increased as far as the number of samples that had detectable levels. So, again, this has had 3 years of neonic treated corn, and there's still detectable levels, at the beginning of each season and at the end.
So do you,
Oh,
did
go ahead.
that, or you got more coming?
Yeah.
Yeah.
So, this is throughout the season. We don't need to focus on this too much. But we were detecting neonics across the season. Okay, so in the water. So these were the 4 points, collection points, where we saw detectable levels of neonics in the tile water or the surface runoff, okay? And detectable levels in this case, it says 0.05 micrograms per liter, but the detectable level was actually, or the reporting limit was actually a bit higher for us because of some of the sediment in the samples. But just to note, you could see how many times we sampled, and these were the only times that we saw detectable levels. So we planted May 15th, and the first time we saw neonics in the tile was on the 16th of June, and you could see the levels were, above detectable, but very low. We saw the most kind of flushing, both in tile and surface, off of the surface and runoff, on the 3rd of July. And if you remember last year, that's when it started really raining. It was a drought really before this. So we had a big rain event, and we saw those neonics in the surface and coming out of the tile. Then from that point, the levels went way down to not detectable throughout the rest of the season. Okay, so, here's rainfall. 2023 is the is this gray line here. And you can see the most neonics were here where these red arrows are, June and July, which corresponded with, rain events following a very dry period. And then after that, we didn't see a lot of neonics or, at detectable levels in runoff or tile. So we saw detectable levels, in about half of our samples. We saw more neonics in the surface runoff than we did coming out of tile at this particular site. And these were the seasonal load, across the entire season. So this is in milligrams of neonicotinoid per hectare. And those are the different, water, those little sub-watersheds. So again, the neonics, they were in the water, they were in the tile and the surface runoff. I think this really brings, minimizing surface runoff into light, right? We want to minimize that for water quality in general. But there is some of the neonicotinoids, coming out of the tile, especially, there seems to be this first flush. And after that, we don't see detectable levels, into the, we didn't see any into October, November, December, and even now.
And when was the corn planted in that area?
May
Was it-
15th.
Yeah.
Okay, so I know we're running out of time. I don't want to not be able to take questions. We've done some more projects, so, I could talk about those, or we can take questions too.
Yeah,
Just so.
so,
This is helpful.
So we have been doing some monitoring on farms, and we've done some research experiments up at Borderview Farm in Alberg with Roger Rainville, looking at planting dates of corn and, how those different planting dates may or may not be impacted by wireworms with treated and untreated seed. And, I'll just cut to the chase here. This is the seed corn maggot flies that we trapped. And we had sites in Addison, Franklin, and Alberg. And you can see the Alberg seed corn maggot flight. The first flight was May 5th. And you can see, we had 250 maggots on this little card. So I got the cards right here. I'm going to put them out today. So, we planted the corn, our corn up at Borderview Farm on May 9th. Okay, we saw the second flight on June 8th. So you can see another increase. Outside of that, you see, the maggot numbers go way down. So there's still pressure, but not a lot of pressure. And then they go up and then they go back down. So you can see those different generations. Now, most of the time, corn, is going to be planted. Again, really people try to get started as soon as they can in May. The average planting date is mid-May through the end of May. So, it's hard to say if somebody planted right around this time, they may have a lot of damage, but outside of that, they may not. Last year was really cold, actually. And so you can see our other flight at the 8th of June, could have impacted corn that was planted later. We were really behind on GDDs last year. Like I said, we're almost ready to see the first flight, and it's April. So we didn't see our first flight last year till the beginning of May. And that's why this is, it's unpredictable in a way. Addison County, I think we missed the first flight. We weren't trapping early enough. So we're putting traps out today. Franklin, we didn't see really our first major flight till the 8th of June. It's colder there. So again, it's going to differ throughout the state. These are the corn populations at these different sites. And you can see that, so we had treated and untreated seed. The treated seed is in blue and the untreated seed is in brown. We saw like these differences, but this one in particular in Franklin had nothing to do with seed corn maggot. And in Enosburg as well, we had a ton of bird damage. So we didn't see a lot of damage or any really from seed corn maggot at these sites last year. At the Alberg site, we measured yields, and we didn't see any difference between treated and untreated seed yields, except for the last planting date. And you can see we had 36 tons of corn silage in treated seed, and we had 32 in untreated. If you remember, that's when we saw this flight.
is that number in tons or what?
Tons. Yep. Tons per
Tons?
acre. Yep. So this planting date was the same time as that seed corn maggot flight. So we did see this kind of yield reduction. Again, it was timed with the seed corn maggot flight. And, we got to keep monitoring and trying to understand patterns. So, yeah, I know we're running out of time, so I don't want to keep going. We looked at soil there as well. And, we saw detectable levels at the end of the season and at the beginning. So the material sticks around, which is, I'm sure, what you've heard already.
Had there been treated seeds planted in the treated area the previous year, or had it always been untreated seeds planted?
Yeah. So at the Alberg site, we went into an area of the farm that had not been in corn for a long, long time. And we were still picking up detectable levels at 2.5 to 6 inches in 75% of the samples. And I actually couldn't really figure out why. There was nothing on the surface because we hadn't planted corn there. But then I went back through all my records of different research trials that we had there. And there was a summer annual trial, so like a sorghum, Sudan grass trial, where we did have some of the varieties that were treated. So it certainly could have, we could have been seeing those levels from that. So the intent was to have it someplace where we didn't have any.
Yeah.
Yep. Which we'll try again this year.
So Dr. Darby, this is ongoing research that you and your students are doing. So it's
Yeah.
one of
Yep,
these things
so-
we can loop back to you again on.
Yeah. So we're repeating the work we did last year. We are doing more on-farm sites where we're planting treated and untreated corn seed. We're trying to find fields that are coming out of sod so we can see the effect of that. We'll continue water monitoring and soil monitoring. We will be looking at movement of neonics in dust coming off planters this year, and looking at alternative treatments as well.
And do you think the 29 is out far enough to get good enough research to develop a type of product that will protect our land base from being like that previous cornfield you showed us?
Yeah, I don't know. 5 years isn't a lot in the research world. Maybe if you had unlimited resources, but we don't have that. We are partnering with Cornell and doing some work with them to try to build more data faster. But yeah, 5 years isn't a lot of time. We only have one growing season a year, so, and everyone is different. And again, we're pretty limited in what capacity and resources, it takes money to do all this.
We had farmers in from Franklin, New Orleans, and Addison County yesterday, and their seasons were all different, and
Yeah.
some said within their own county, they could do certain lands in one area, but couldn't do it in another because it hadn't warmed up enough, or vice versa.
Yeah. Yeah, just with our trapping data, a pest, just even the difference between Alberg and Franklin, we're not that many miles away, but the climate's really different.
Yeah.
So, and again, just understanding how today's practices influence this pest. There are new pesticides we'll start looking at this year. I don't know if, this doesn't really solve the problem, which is people don't have options. Options to plant this corn that they want and be safe, make sure they're gonna get a crop, so.
Thanks. Yeah, Dr. Garber, when you mentioned climate, I'm just curious, do you have any idea how many little microclimates we have in this state? Because people talk about them more and more that, if they travel down, a slope, they get this little microclimate. I mean, are they just everywhere?
Oh, yeah. I feel like
Okay.
it's even more so now
Okay.
than it used to be. Roger Rainville, who's a quarter mile from my house, got 1.5 inches of rain yesterday, and we got 1/4,
Yeah.
So even that distance is
Yeah.
incredible.
Thanks. I'm just curious, they're really interesting to me, and
Yeah.
I'll loop back to that questions. Thank you.
And have you done any work with, on the, is it dynamite?
Yeah, the diamides.
Dynamite is.
Yeah, we will this year. Yep, we have some seed coming so that we can evaluate it.
Yes.
To make it, yeah.
Other questions
thank you.
for Heather?
I gotta head upstairs.
No, well, we really appreciate your time, Heather, and, thank you very much.
Yeah, if you have any other questions, please feel free to reach out and I can send this presentation to Linda.
That'd be great.
Yeah,
Thank you.
very good.
Okay, have a good day.
Thanks,
Bye-bye.
Bye.
So. That, stuff. Yeah. No, it's kind of crazy, we're at the mercy of people selling us stuff and, you use the old type system and that didn't work that well. And then you get the new stuff and, 20 years later, you get zapped and it's, those, worms and earth maggots are ugly looking things. Anyways, I guess, is there anything else at the committee? I know we got meetings, so,
Yeah.
and you folks, sorry about
Yeah, it's again.
putting you off,
You got to relax for a while.
well, if there is a way to relax, thanks for coming over and
Sure.
We're coming over, watching over.
We were-
No,
We